Addition reactions occur when inorganic molecules react with unsaturated organic compounds. In other words, there must be a double or triple bond present for an addition reaction to occur. During this reaction, the double or triple bond will break and atoms will add onto the carbon atoms on either side where the double bond was. The unsaturated organic compound now becomes saturated. To decide whether a reaction is an addition reaction, you should look at how many reactant and product molecules you have. In addition reactions, you should have 2 reactants and only 1 product. Also look for unsaturated reactants and saturated products. The first type of addition reaction is the addition of hydrogen. The special name for this reaction is hydrogenation. If we look at the example of propene, we see the double bond breaks and one hydrogen atom is added onto the one carbon and the other hydrogen atom is added onto the other carbon. The propene now has become propane. Therefore, during this reaction, alkenes or alkynes become alkanes. This reaction is catalyzed by using either platinum, nickel, or palladium. The second type of addition reaction is the addition of a halogen such as bromine water, chlorine gas, fluorine, or iodine. The special name for this reaction is halogenation. Sometimes the word bromination is used for the addition of bromine, or chlorination for the addition of chlorine, and so on. During this reaction, the double bond in the propene molecule breaks, and a halogen is added onto each of the carbon atoms. The alkane has now become a haloalkane. This reaction is very spontaneous and occurs very quickly. Therefore, no reaction conditions are necessary. In fact, this is one of the reactions that is used to test for saturation. When bromine water is added to an alkene, the reaction mixture discolors quickly as the bromine is added to the alkene. The next type of addition reaction is called hydrohalogenation. This is the addition of a hydrogen halide, such as hydrogen chloride, hydrogen bromide, hydrogen iodide, or hydrogen fluoride. During this reaction, the double bond breaks, and the hydrogen atom attaches to the one carbon and the halogen to the other. We can see that during this reaction, 2 products are possible, a primary halide or a secondary halide. To determine which product will be the major product, we turn to Markovnikov's rule. This rule states that during an addition reaction, the hydrogen will rather attach to the carbon that contains the most hydrogens. Therefore, the hydrogen will rather attach to the terminal carbon and form the secondary halide as its primary product. If we look at the hydrogen halides, we see that they are all acids. Therefore, it's important that no water be present during this reaction. If water is present, the acid will act like a catalyst and add the water to the organic compound instead. The last type of addition reaction is called hydration. In this reaction, water is added onto the alkene. The double bond breaks and a hydrogen from the water adds onto the one carbon, while the hydroxide from the water adds onto the other carbon atom. We see that during this reaction, alkenes become alcohols. We use Markovnikov's rule to determine the major product. According to the rule, the hydrogen bonds to the carbon that already has more hydrogens, while the hydroxide bonds to the other carbon. So the hydrogen bonds to the terminal carbon, forming a secondary alcohol as the major product and a primary alcohol as the minor product. The reaction conditions for this reaction is a strong acid catalyst, such as sulfuric acid, and heat.